All right, hello guys. You should be on page 150 in your student journals. I did fill in some of this already, so you can feel free to pause and copy and whatever you need to do. I'm planning on hopefully remembering to post these to Google Classroom also, so you can always fill them all out first if you want, and then watch the video, or watch the video and then fill them out. Do what you gotta do. Okay, so inverse functions are functions that undo each other, just like inverse operations, so squaring and square rooting, adding and subtracting, multiplying and dividing, cubing and cube rooting. So I wrote a couple examples of inverse functions, and what you'll notice is not only do they have inverse operations, but they have them in the opposite order. So like this, if we look at what's happening to x, we are multiplying by 3 and then subtracting 2. So in the inverse operation, we're adding 2 and then dividing by 3. So multiplying and subtracting, adding and dividing. So same, I don't know where I was going with that. Same, not the same, different. Opposite operations in the opposite order. Okay, and then I did another one. We have the square root of x plus 1. So we're adding the 1 first because that's inside, and then we would take the square root. And here we're going to square it, and then we would subtract 1. So again, opposite operations in the opposite order. So a lot of times our inverse is not actually a function unless we restrict the domain. So if you think about squaring and square rooting, you know, a square function is a full parabola, whereas the square root is just a sideways half of a parabola, and that's because if we had the other half, it wouldn't pass the vertical line test anymore because it would no longer be a function. So you can test the original function to see if its inverse would be a function or not by doing instead a horizontal line test, because what happens is your inverse functions swap domain and range. So if your, like here is, you know, the x squared graph. If I flip this on its side, then it's not going to pass the vertical line test because my x's and my y's switched places. So now instead of having my, you know, regular parabola, it would be a sideways one. Here you can see that we've got a little horizontal line here, and if I were to kind of shift this all the way down, it would never hit more than 1 point. So that one's good, that one's not good, and I highlighted where those 2 points would be. And that's just one instance. Obviously, if I drew another line here or pretty much anywhere else on the graph, it would still be hitting 2 points. So just a couple of notes. Inverse functions swap domain and range, and each ordered pair is reversed. So you can see I wrote down just 4 random points for my original function, and then this has the same pairs here, only all my x coordinates and y coordinates switched places. So instead of having the point 1, 2, I have the point 2, 1, and that happens for all 4 of these. So if you're ever looking at a table of points or a list of ordered pairs and you're asked if these 2 functions are inverses, you have to confirm that every single ordered pair of 1 is swapped in the other function. Okay. So first few examples, what we're going to do is we're going to solve this equation for x. So we're going to get x all by itself, and then we're going to find the input when the output is -6. So to start, I'm going to replace this f of x with y, just to make it a little bit easier writing. And now I want to get x alone, so I'm going to add the 1 over. So I have y plus 1 over here now equals 2x, and then I'm going to divide both sides by 2. So y plus 1 over 2 equals x. So now you can see normally we plug x in because that's the easier one, that's the independent variable. And in this case, if I plug x in, that doesn't really help me out, but plugging y in would. So y goes with the output, so I'm going to replace y with a -6 here. So I would get -5 over 2 And I can either leave it like that or call it negative 2.5, you know, doesn't really matter. Okay, so if we want to look at number 2, if I want to get x alone, first I got to move the 1 over, so I'm going to subtract it. They don't leave you a lot of room here, I hate that. Divide both sides by the negative 1. So then I'm going to have negative y plus 1. And now I need to square root. So the square root of negative y plus 1 is going to equal x for me. So now if I plug negative 6 in, I'm going to have negative 6, so positive 6 plus 1, which is the square root of 7 for x. Okay, I'm going to skip 3 for right now. I'm already at 6 minutes, so I just want to make sure I don't take too much time. So what we were doing here, when we just kind of got x all by itself, that's really similar to how we find the inverse of a function. The only difference is we first swap out x and y. So for instance, if you look at number 4, and I say that this is y equals 10x, the first thing I'm going to do is I'm going to switch x and y. So I'm going to have x equals 10y, and then get y all by itself. So x over 10 equals y, except it's not really y, nor is it f of x anymore. Instead, it's f inverse, which we write this way. We put like that little negative 1 power, essentially, and this is read as f inverse. So I'm going to kind of write that up here. Which, notice this is kind of to be expected. My original function was 10 times x, which is just one operation, and my new inverse function is x divided by x, so that makes sense. Okay, so now if I look at number 5, I'm going to do the same thing. I'm going to call that y, and then I'm going to swap it out with my x. I'm going to write this over here because I don't really have room otherwise. So now I'm going to get y alone. So I'm going to add the 7 over. And now negative 1/5 y. Remember, I can divide by negative 1/5, but that's the same thing as multiplying by its reciprocal, negative 5. So I'm going to do that instead. So negative 5x minus 35 equals y. And again, this isn't really y anymore. It's f inverse. So we write it back in function notation, but with that little negative 1, so we know that it's the inverse function. Okay? So we're not worrying about graphing, so that's all that you got to worry about here. Now, these last two problems on this page determine whether each pair of functions are inverses. That's what we were talking about with the ordered pairs earlier. So if you look, we want to make sure, go through every one of these ordered pairs, see that it's in reverse, you know, the x and the f of x are swapped. So here I have negative 4, 17. Here I have a 17, negative 4. So that one's good. Negative 3, 13. 13, negative 3. Also good. Also good. Also good. Good. Not good. This was 1, negative 3. Now it's negative 3, negative 1. So because that's not a positive 1, it doesn't work. So we would say no. Okay. So if we check out number 8, you can see these are all actually like like this is 1/8 and that's 8. And so that's not working out for us either. What did I do with my paper? Okay. So this one didn't work out either. How odd. I wonder if that was a typo and was supposed to be a positive one. However, so let's just kind of note, like if this was a positive one, when I run into the bottom, I can't write anymore because my hand's not holding the paper down. So if positive one, then yes. Okay, so good enough. Okay, anyway, and so then this would be the same reasoning, that none of these work, so no. All right, cool. So next page, we're gonna do some more find the inverse of the function. And again, we're not gonna graph. Hold on, let me just cross this out really quick. Okay, so if I wanna switch these, y equals x plus 2 to the third, I'm gonna swap out x and y. So x equals y plus 3, oh crap, y plus 2 to the third, there we go. So if I want to get y alone, I gotta undo this cube part first. So I'm gonna have to cube root both sides. So cube root of x equals y plus 2, and then I'll just subtract my 2 over. So cube root of x minus 2 equals, and then again, remember y. We'll really write it back in function notation again, but this is the inverse, so we'll put that little negative first power. Okay, looking at this one, if I rewrite this with a y, and I'm going to swap them out. Okay, so the first thing I can do here is get rid of this 1/3, so I'll multiply both sides by 3. And then I'm going to have to 4th root both sides. So the 4th root of 3x is going to equal my inverse function. Okay, so looking at 11 and 12, we talked about the horizontal line test just earlier in the notes, so you can see here this hits multiple points, so it's not going to be a function. Nope. Fails the horizontal line test. Looking at this one, it also fails. That one hits 3 points. Okay, and then questions like this say, determine whether the functions are inverses. Normally, we would use function composition and plug one function into the other and confirm that we get a certain answer and then do it the other way. And instead, what we're going to do is we're just going to find the inverse of one of them and just confirm that our result is the other function. Okay? So on this one, you could do either of them. I feel like we've done more like this type of a problem, so I'm going to do g of x. So if I replace g of x, call it y, 5x plus 1 over 4. I'm going to swap out x and y. For whatever reason, when this happens, kids get confused. But keep in mind, this whole thing is being divided by 4, so I can't get y alone at all until I get rid of that first. I can't move the 1 over because it's also being divided by 4. So multiplying by 4 is definitely the first thing we're going to be able to do. So 4x equals 5y plus 1, and then gets pretty basic from there. So we'll subtract 1 from both sides. 4x minus 1 equals 5y, and then divide both sides by 5, and hopefully you can see already that these are not going to be inverses of each other. Because over here, this 1 is not being divided by the 5, whereas in this one, the 1 is being divided by 5. So we would definitely have to say no to this. And if you ever do one like this and you're like, ooh, maybe I made a mistake, well, then you can try it the other way and, you know, check that way. But these don't work. Okay, so looking at 14, I mean, neither one of these is like super spectacular, so I guess it doesn't really matter. But so I'm just going to do the first one this time. Oh, I need something to hold my paper down. I'm just going to kind of re-angle this. Okay, so set my, can I do that? Yeah, sort of. All right. Okay, so now I'm going to swap out my x and my y. So I'll have x equals negative y minus 2 to the 5th. So I can get rid of this negative first. So negative x equals y minus 2 to the 5th. And then I'm going to have to take the 5th, take the 5th root. Oh my gosh, I forgot the 6. I'm like, this isn't working out. So hold on, let me see if I can fix this or not. Well, not here anyway. Okay, so instead, oh man, I really butchered it. I could have done it there. Anyway, yeah, okay, so I gotta switch the x and the y again. I'm sorry, guys. X equals, yeah, okay. There we go. So now we got to move the 6 over first. Then we'll be able to divide by the 1, the negative 1. There goes my chances for YouTube fame. Okay. So now we'll have to take the 5th root. So the 5th root of negative x plus 6 equals y minus 2, and then we'll add the 2 over, plus 2, plus 2. So I'm going to write over here to the side now. Plus 2 equals y. Alright, so now I want you to notice negative x plus 6 is the same thing as 6 minus x. And the 5th root is the same thing as being raised to the 1/5 power. And of course, a 2 plus in the front is the same as a plus 2 in the back. So this one works. So g of x does equal f inverse of x. So yeah. All right, cool. So now we're done with the notes. Sorry you had to suffer through that. I know that it's not nearly as good as when I do notes at the board and give you the opportunity to ask questions and blah, blah, blah. Remember, you can pause, rewind, replay, do what you got to do. Ask Mr. Thomas. But now there should be a practice worksheet readily available for you to work on, and you need to practice it. We are supposed to have a quiz on Monday. We'll play it by ear. Right now, I'm planning on having it. So do this practice, okay? And we'll talk Monday, and I hope you have a great weekend. Be safe, be smart, get your work done. Homework checks, homework checks, homework checks.